What is meant by notch? A notch may be defined as sharp-edged obstruction over which fluid flow occurs. The notches are classified into four types depending upon the shape, that is rectangular notch, triangular notch, trapezoidal notch, and step notch. Then what is the uses of notches? The notches are mainly used for the measuring the rate of flow of liquid from a reservoir or from a small channel or from a tank. Then triangular notch has advantage of greater accuracy at reduced flow rates compared to other shapes. Yeah, in case of triangular notch, it will give good results compared to the rectangular notch. Why? Because in the rectangular notch, because of end contraction forces, the discharge is going to decreases. So in the absence of end contraction process in triangular notch, it will give more discharge and accurate results. Let's there is the importance of the notch. Let's begin with the experiment. So what is the aim of the experiment? The aim of the experiment is to determine the coefficient of discharge for a given notch. Then to conduct the experiment or to perform the experiment, we need apparatus that is known as test rig details. What are the apparatus we need? That is a notch in an open channel provided with the hook gauge to measure the head over the notch. Then a discharge measuring tank fitted with piezometer and a graduated scale. Then after that, storage tank that is known as sump and a centrifugal pump along with this stopwatch to note down the time. So these are the equipments or apparatus we need to perform the experiment. Next, coming to specifications. Specifications are nothing but, so before conduction of the experiment, we need to note down the specification part of the equipment. That is the first one. What you'll go to note down the angle of the notch, that is theta in terms of degrees, whether 60-degree notch or a 90-degree notch, you have to note down. Then after that, length of measuring tank, that is L in millimeters, you'll go to note down. And then after that, breadth of the measuring tank, that is B in millimeters, you'll note down. Then after that, area of measuring tank, that is in millimeter square. If it is in a rectangular shape, if the tank is in rectangular shape, then L into B, it will give the area of the measuring tank, that is in a millimeter square. You have to calculate and you have to keep. Then coming to procedure. So procedure is nothing but, before during the conduction of the experiment, you'll follow certain steps. That is a procedure. First step, what you're going to follow, you just see here, place the notch under test at the end of the approach channel in the vertical plane with a sharp edge on the upstream side. Then after that, record the geometric shape of the notch. After recording the geometric shape of the notch, what you have to do, allow the water in the tank till it just passes over the notch, that is up to crest level, and by that time make the flow steady and set up 0 in hook gauge, that is known as your initial reading H1. After that, just start the water supply and record the water level by the gauge when the water just passes over the notch, that is known as H2. This H2 is a final reading what you have taken. Then the difference of H2 minus H1 will give head over the notch. Next, after that, collect the water discharging from the notch in a measuring tank and measure the rise of water level, but for our centimeter rise in the tank for a certain period of time in seconds. Then after that, repeat the above procedure for various discharges by operating the regulating valve. So these are the steps you have to follow during the conduction of the experiment. Next, once procedure part is over, next one is tabular following. You have to tabulate the readings. So that one, first one you can see. So 3 trials, if you are going for 2 trials or 3 trials, you just note down, that is just right here, serial numbers. And after that, hook gauge readings, that is in millimeters. So H will be equal to main scale plus vernier scale into least count. That will give gauge reading. That is H1 is initial reading. H2 is the final level, initial water level, final water level. Difference in water level will give the capital H. Then R in centimeters, that is the rise of water level in the measuring tank. Then T in seconds, that is the time taken for rise of water level in the measuring tank. That is in seconds what you'll want to note down, and you have to tabulate the readings here. Then now once if a tabulation part is over, next one is a calculation part. So what are the formulas here you're going to use to calculate the coefficient of discharge? That is the first one. So Q actual, that is nothing but actual discharge. So actual discharge can be calculated by using formula AR divided by T, where A will be equal to area of the measuring tank in millimeter square. Then T will be equal to time taken for rise of water level in the tank, that is in seconds. Then R will represent rise of water level in the tank for known time T. Then once after getting all these values, just substitute it here and you can calculate your the actual discharge. Next, theoretical discharge. Once if you calculate actual discharge, theoretical discharge also you can calculate. So theoretical discharge will be different for different shape of notches. For rectangular notch, it will have a different formula. For a triangular notch, we'll have a different formula. For trapezoidal notch, we'll have a different formula. In our case, we are using triangular notch. For triangular notch, so this is a discharge Q theoretical discharge equation. It is 8 by 15 into root 2g into tan theta by 2 into h to the power of pi by 2. That will be equal to k into h to the power of pi by 2. K is nothing but the coefficient. K is nothing but constant. So that constant will be replaced by 8 by 15 into root 2g into tan theta by 2. Then theta is your angle of notch. Whether if you use 90-degree notch or 60-degree notch, you have to note down. Then you have to substitute here. Then h is your head over the notch in meters. That is h2 minus h1 will give h capital H. Then once after calculating actual discharge and theoretical discharge, then you can substitute in your final discharge expression, that is in quotient of CD, quotient of discharge expression, that is Q actual to Q theoretical, will going to get CD. Then after calculating all these values, that results also just to tabulate here, that is actual discharge, H to the power of pi by 2 theoretical discharge, and final CD values. Then if you are going for 3 trials, all values should be tabulated here. Then finally the result, the quotient of discharge for a given notch, average of 3 values, we'll go to substitute here. That is analytically we'll go to calculate the value, CD value. Then you have to find the graphical solution. Then you have to plot the graph versus H versus Q actual. Yes, after plotting the graph, so you'll go to get on a linear straight line. From that linear straight line, take any 2 points and find a slope. That slope will be equal to AB by BC. Then after calculating the slope value, slope divided by K value in the previous step, what we calculated, that constant value, if you're substituting here, you will going to get your CD, quotient of discharge, from graphically. So this figure, it will go on to represent the head of water which is stored above the notch. That is a H2 minus H1. That will be equal to H. So some of the Viva questions, some of the examiners will want to ask, that is what is notch. So why B notch is preferred to a rectangular notch for a measurement of small discharges. What is weir? How it is different from the notch? Then why do you use a weir? Describe wood gauge, point gauge. What are the assumptions made in the deriving theoretical equation for discharge over a triangular notch? Then what are the Indian standards related to flow measurements? These are some Viva questions they will go to ask. Some examiners they will go to ask. You have a note down. Then thank you.